What we're going to talk today about is it's kind of an ambitious subject, software design. And it's a methodology for designing software, sort of regardless of the programming language or regardless of what the application is supposed to do. And I'm not sure it's going to work in all cases, but and I'm not even sure that this is the best. So if you have any ideas, throw them out because I'm willing to learn. Firstly, I'm going to draw two sort of large rectangles here, and I'm going to try and get through this section of the lecture pretty fast because I want to redraw the diagram using little tiny rectangles. So, but first I want to talk about these two rectangles. And one is data and the other one's code. So these are the two parts that make up all software. I'm trying to apply design principles. Like, we're familiar with object-oriented programming. There's like another level up. It's design patterns, where you start to see that a restaurant, a program to run a restaurant, and a program to run a library are kind of the same things. They're both loaning something out, a table in the case of the restaurant or a book in the case of a library. And of course there's a lot of differences, but there's similarities too. And what's going to come up a lot in application development is that there's going to be lists of things. So multiple lists usually, unless it's a very simple application, but there'd be lists of things. And if do you have a computer science degree, or
no?
Have you ever had a data structures class?
No, I've never had any.
Okay, so in a data structures class, you're probably better off without it. Because essentially data structures classes, the same one that I took 40 years ago is the same one they're teaching today. And things may have changed a little, but in any case, you have lists of things, and usually I pick an application sort of at random. And sometimes I ask people to name any application at all. And then sometimes that doesn't work out. So, it could be running a library, running a university, running a bank. Those are all very similar. You wouldn't think they'd be similar, but in fact they are kind of similar. Bank, library, grocery store. Okay, so a grocery store, and the interesting thing is that as you develop the app, you sort of put it together a piece at a time, and the first thing you do with a grocery store is a list of all the products that you sell. And of course, that would be a record, right? Because there would be a name of the product and I guess a type of the product. And I'm not going to get into details because that's not what this is about. But there would be things like there would be a reorder point, and you would also keep track of how much of the product you had on hand. And when the amount you had on hand fell below the reorder point, then you got to reorder it. You'd also have a list of suppliers from whom you can order these groceries. That's pretty much it for a grocery store. So a grocery store is pretty simple.
Maybe customers, and track loyalty or something?
Yes, but I don't want it to get too complicated. But yes, and and if you don't think so, are you married?
Yeah.
Do you have kids?
Yeah.
Okay, well, usually in a class there's somebody who's not married and doesn't have kids. and I tell them, just go into this grocery store with your credit card and buy some Pampers for a newborn baby. You can return it later. And then watch what happens to your mailbox.
Yeah.
You'll start getting inundated. So yeah, you do keep a list of your customers, but let's, and you'd keep a list of your employees, and you'd keep a list of a lot of things. But you don't just throw everything in the pot and hope that it comes out like good soup, right? So you'd start, I think you'd start with just a list of all the things you sell. And already you've got something that's going to be useful to somebody who's running the grocery store. I'm thinking more in terms of a mom and pops, because it's going to be different for Walmart, because But in any case, so these lists, now there's a lot of different ways to implement it. You can implement it as an array or a vector, which is just a wrapper around an array. You could implement it as a sequential file. You could implement it as a random access file. You could implement it as a SQL database. It goes on and on. You could implement it as a hash table. You could implement it as a BST, a binary search tree. All that's pretty easy to do, and there's different reasons why you'd pick different ones for a list, right? If it's going to be small enough to fit in RAM and you want the whole thing to run pretty fast, you might just make the whole thing an array. If it's not going to fit in RAM and you're going to need complicated queries into it, you'll want to do it as a SQL database, perhaps. There's a lot of different options. C# is kind of cool because it's got that thing where you can sort of use SQL type queries to get into other data structures. So, and I try to make this agnostic in terms of programming language, but C# is really cool. In any case, you're going to keep running into these list things. And most programming languages have all these methodologies for implementing lists, different types. If you pick the wrong one, then you have a potential design problem down the road, because if you decide, oh, well, I'll make it in memory and make it real fast, and you make it a vector, or just, that's like a wrapper around an array. Okay, that's what it would be called in C++. In C, C#, it would just be called a list, which is a very good choice. There's also a BST, and the BST is the only one that's not a good choice. So, and this is the advantage of having not had a data structures class. The BST is a very interesting data structure where everything is in a giant binary search tree. And theoretically, it can access stuff real fast. But that's theoretical, and in actuality, it's really not very good at all. Because and since you haven't had a data structures class, I won't try and talk you out of the BST. But the basic problem with it is that CPU speeds have gone up exponentially and memory speeds have gone up linearly. And so as time progresses, RAM is the bigger and bigger bottleneck. And the approach that we use to solve the problem in current hardware is to have something called cache. And so cache just means that there's a small amount of really fast memory right on the silicon with the CPU. Then there's another layer of cache that's, well, this is, let's see, fastest, faster, And there may even be a couple more layers of cache, and then eventually get to RAM, which is the bottleneck, and it's slow. And the idea is when you access memory, and it doesn't happen to be in the cache, it's called a cache miss. And it'll go to the next level of cache, and if it's a cache miss there, it'll go to RAM. And then it takes not just the one piece of memory that you want, but memory, all the memory around it, and brings it into the cache. And then from there, it'll do the same thing again. So when you access memory, anything that's close to it will also be fast. And that's your problem with your BST, is that it tends to fragment because it's all hooked up with pointers. So as you add things, they're spread all over memory. And so every time you access something, it's likely to be a miss. And so it's going to cause this whole cache of cache misses. And it's going to cause all this memory to be blocked up into cache. And then that's not going to help you for the next one. Because the way it works is every record has the left and right pointer that points somewhere into space. Now that's why it's called a binary search tree. In theory, it's fast. And when they first started teaching it, it was a good way to go because you only had RAM. You didn't have this cache architecture. Someday, they may make it so that all RAM is really fast. And then they'll do away with the cache architecture. And then BSTs can go back to being good again. But it doesn't matter. So in any case, everything's good except for cache. Except for the BST. And oddly enough, just arrays actually are really a good way to go. Even if you're going to do random access into them.
I tend to use a lot of dictionaries.
What's that?
I tend to use a lot of dictionaries.
Okay, so we're going to talk about that because, see, there's things associated with the lists. And that's going to be indexes. So a way of getting to somewhere in the list fast is not inherent in a vector. So you can create a hash table, which is what a dictionary is. So in C#, they implement dictionaries as hash tables, unless it's a sorted dictionary. Then they're going to go with something like a BST, which, so the disadvantage of the dictionary or the hash table is it doesn't give you sequential access. But you've already got that because the list can be sorted into whatever your primary index is. And so that's the basic strategy, is to keep your lists and vectors. And then you have two things. You have indexes into lists, and in C# you use a dictionary, and in the other language you find out how they implement a hash table, because then that's going to give you the fast access. And you also have associations between lists, and the associations can be one to many, many to many. There's different ways it can go. Like if this was a library and we had a list of books and a list of patrons, the relationship between the patrons and the books would be one to many. Each book can only be checked out by one person at any given time, but one person can have many books checked out. In the case of a grocery store, you'd have a list of suppliers and a list of things that you sell, and it would be many to many. So there might be multiple suppliers from whom you can get I don't know, Swiss cheese or whatever it is, and each supplier would have multiple products that they would provide for you. And so besides the index, there's also an association. And to implement this well, oh, I should say this. So I'm saying a vector is your best data structure. In fact, your best data structure would be a hybrid. Well, there's actually a couple different ways you can go. You could make a common interface to all these different lists. And in C#, it's almost there for you already. And then all you need to do is create a cast so that you can turn any kind of list into any other kind of list. And yeah, let's say there's 8 or 9 different types of lists that you could implement. So that would be 81 different casts. But you don't really have to do that. You have to do everything to a vector, and then from a vector to everything else. So it's really only 17 different casts that you'd have to make. This is just stuff, and once you've done this, you know, you're gonna sell the same application to so many different people that it's gonna be worthwhile. Now the other alternative is you might say, look, it's always gonna be vectors, unless it overflows, right? Because one of the big design errors you can make is make your application not scalable. So you make it, it works fine. You know, you show it off to the grocery store company, and they, you know, and you've got 12 grocery items and 4 suppliers.
And they put 10,000 items in.
And they put in 100,000. The grocery store will have 100,000 items, and that they might sell at any given time. Remember, some of it's seasonal. You know, come Christmas, there's different stuff, and
That's like a
Halloween has different stuff.
Excel until recently could only do 65,000 cells or rows.
Okay.
You couldn't make it any bigger than that. You tried to paste in some data that was, you know, 66,000 rows. No error. There's not enough room. Couldn't do it.
And
Same
now
with
they've,
character.
now they've gone beyond that. I use
think so.
LibreOffice, so
Yeah,
I don't know about Excel.
I don't know anymore. But
Anyway, so I would recommend a hybrid. And the hybrid is, it's a combination of a SQL database and a vector. And you can come up with some sort of scheme for when stuff is in the SQL database and when it's in the vector. And most frequently used is a very simple algorithm. So it really comes time that when the vector fills up, what's going to be rolled out to the SQL database, and whatever was used least frequently, you know, is going to optimize, well, may optimize your application. The other thing too, in that case, you have to keep a Boolean with every record saying whether or not it's dirty. So has it changed since it came in from the SQL database? And if so, you gotta write it out. And if not, you don't have to write it out. So you might even come up with a strategy of like the least frequently used list item that's not dirty, because then you got nothing to write. If you want to move a bunch of dirty items over into the SQL database, you might do that as like an overnight update type thing, so that, you know, if the application gets really big, you know, it's not going to just like freeze up for a minute or two while everybody wants to use it. Anyway, so that's the list. A little bit more detail about that. Every item should be accessed by an integer ID number, which is not its location in the array, right? So the array would be 0, 1, 2, 3, 4, etc. But then if something gets inserted between 2 and 3, then you've got like a bookkeeping nightmare of like updating all of your indexes and associations. And so everything should have an integer ID, because it may not even be in the array. It may be off in the SQL database. And so, but you want this to be transparent. You want to overload your square brackets to use the associated ID number. So the ID number goes here, not the index. And then the square brackets is overloaded so that it's going to use a very quick hash table to go find the item, whether it's in SQL or if it's in the vector, and it'll be transparent to the programmer who's doing the coding at that time. Okay, like I said, there could be a many-to-many, like this grocery item could be supplied from 3 different suppliers, and this supplier right here could have like 40 or 50 items. And you can do that by keeping another data structure, which is an association. Again, it'll have an indexer to get into it. So if you go into the association, then essentially it's just keeping these records that are lists of integers. So it'll be, so if you go to this supplier, then you hash table his ID number into the association, then it'll give you a list of numbers, but those are the ID numbers of the grocery items that it supplies. And the same thing works in reverse. So the ID of a grocery item can be used with an association to give you a list of all the suppliers that supply that. And that's all based on hash tables. And know about big O notation?
Generally.
Okay,
yeah.
so theoretically, a hash table is big O of 1. It really doesn't increase in, as the hash table gets bigger, it doesn't get slower.
The computational
That's
complexity.
sort of theoretically impossible, because it really, this big O is the limit as n approaches infinity, and hash tables will break down at a certain size. And so you can make them as big as you want, but if it gets bigger than that, then it won't, when it won't be the big O, it'll actually revert to a sequential search. And that's really slow. So, but in practical reality, it's big O of 1, so those dictionaries are always going to be good for you. Get more memory. Memory's cheap, right?
Yeah.
So, okay, so that's really all I want to say about the data side of it. That's the pattern that data falls into in all applications. You have lists of things. You want to have index. Oh, you can have multiple index. Like it's a university, you'll look up students by their number. You want to look them up by their names. Look them up by their major. So you can have as many of these indexes as you want. And the same with the associations. So students can be associated with what class they're in. They can be associated with what department they're in. They can be associated with their name, with their ID number. You can have a lot of different indexes to get to a student, depending on how your application wants to look at these things. And that's not really what the lecture's about. I just wanted to cover that sort of quick. Over here, the code ends. Okay. So essentially, you want to make an API, a functional API, and you want to make it top-down. So the first thing you do when you write an application is sort of get a rough idea of how the data's going to look. But it may change a little bit as the design progresses. But now you got to write some code. And you got to think about what does this application do? And you want to do a top-down design, which means you go to the highest level of functionality and decide what it's going to do. So let's keep flipping from application to application so that we don't get confused that this is specific to some application. So let's just say it's a bank. So what do banks do?
Track of your money.
They take your money. I'm sorry. I've already figured out sort of what order it goes in, but that doesn't matter. You can figure it out later. Let's see the functionality. Transfer money from one account to another. And so this transfer operation would have two arguments, like from, three arguments, from, to, how much. This is a very high level function. I mean, if a bank can't do this, then they're not going to be able to do any banking. You're going to open accounts. And there's parameters to these things. You know, I don't know what, you know, the type of account, who it's for, what their social number is. I'm not, you know, this is not about banking, but these are very fundamental operations. So withdraw, deposit. I'm thinking transfer from, to, how much. That could be like a wire transfer outside the institution, or it could be like a transfer inside the institution. And so you just start listing all this functionality. And this is where people bog down a little bit. And you know, this is not, I recommend object-oriented design. And I recommend creating an object that's very big. Call it the bank, right? And these would be methods within the bank class. But it doesn't have to be object-oriented, you know. For me, it would be, but not for everybody. And that's not what this is about. It's not a methodologies class. It's like how to design stuff. Okay, so you got these high-level functions. And these are things that you would do if you were going to run the bank manually. You know, hard to believe, but you know, 60 years ago, or I don't know, maybe 70, 80 years ago, people did all this stuff without computers, and so they would come up with some process for transferring money, opening accounts, withdrawing and depositing things, and let's see, open accounts, not quite the same as add new customer. And of course, a lot of these will have a symmetry to them. There's a close account and remove customer, I don't know. And notice a lot of these things almost come for free because you've already done this whole thought process, like what do I do with a list? Well, I can add things, I can remove things, I can rearrange the orders, I can, you know, I can get to things, I can change a specific item within the list. And so having already built that functionality, and that's kind of the bottom up part of this as opposed to the top down. And normally I don't recommend bottom up because you end up writing a bunch of code that you end up not bothering to use because you didn't realize that at the top nobody cares about this little function or that little function. But lists are so common, and things like adding and removing from lists is so common. And you're going to have written it already because this will be the third time you've done it. And so you did it for the last two, and so it's already there. So it goes pretty easy. It's a thing like open account, close account, add new customer, remove customer are almost built in because somewhere there's a list of customers and somewhere there's a list of accounts. And of course there's associations. And it could be many to many because you could have an account with multiple owners, like a husband and wife or maybe partners in a business would have one account that they both own. But more likely it'll be that different individuals have multiple accounts. So, but if you make it many to many and you only make it one in one way, you haven't lost anything. Although the effort involved in the association is a lot less if it's only one, because you just have to have an integer that you look up as opposed to a list of integers that you look up. Okay, so now you've built this whole thing. You know, the problem, the biggest problem with design is to tangle it up with the interface. And it is so easy to do with languages like C#. Have you used Windows Forms or Windows Presentation Foundation?
Windows Forms, yes.
Okay, so you make Windows Form.
I don't understand WPA.
It's the same. It's not a big deal. It's not that XAML thing that I don't care for. I don't even use it. I construct everything outside of XAML. But in any case, so you create a form, you add a button, and you make a drop-down list, and you make a little slide bar, you know, whatever it is. And that's so cool because, you know, it's like playing with paint, you know. You just make it, and it's there. And then you go to your customer, and you go, look at this. This is your application, you know, and that was only a day ago. And now they're certain, oh, you're the one. We've been looking for you to do this programming because, look, in a day you've already come up. Now, nothing does anything because you know, they play with the slider, nothing happens. They push the button, nothing happens. But they can imagine, you know, that they pushed the button and opened a new account or whatever it is, right? And it's then too easy to create an event handler for that button and put the code for opening the account and hang it on that event handler. And that is a disaster waiting to happen because the interface will keep changing. You know, I mean, subtle things like, we don't like that blue, we'd like it orange, or, you know, all that crap. But then there'll be other things that come up where they'll say, we don't want, you know, we want a touchscreen kiosk in the middle of the bank. And so suddenly, none of this works anymore. So you have to go build another interface. Now it all has all these event handlers too, so then you make the event handlers match between your event handlers in your Windows application. And then about then, they'll say, we changed our mind. We want one of those, they won't say this, but one of those horrible telephony interfaces, you know. Like press 1 if you want to open an account, press 2 if you wanted to make a deposit, press 3, you know. And then you go, oh crap, all my event handlers that I wrote for these two other applications now, because you have a touchscreen kiosk plus a Windows app that I don't know where it is, and now you've got another one. And each one has its functionality like tangled up in it. And, you know, It never ends, the change to the interfaces. So, you know, there's a story that once the customer made no change to the interface because he was hit by a bus as he was crossing the street, to tell you about another change he wanted to the interface. And so you don't want to do that. These are nice interfaces and they're nice mechanisms for building interfaces, but you don't want to make that kind of interface. And oddly enough, you want to go old school and pretend that you're in the 1950s and all you have is a console. And so what you want to do is create a command line interface. And I'm not saying that anybody wants a command line interface. They don't. But you want to make a command line interface. And the cool thing about the command line interface is it has the exact same structure as your functional APIs. And so there's a place where you can type, right, and whatever it is, transfer. And it doesn't have to have the exact same syntax, but it could. So you can say transfer from to and how much. It could get complicated. This could be a recurring transfer. So it could happen every 17th of the month. Or it could be just a one-time transfer. So there could be many more parameters. But this is not about making a banking app, and so I'm trying to keep it simple. So there is a command line interface where you can type this stuff. What does that mean? Well, it means you can start testing the functionality of your program right away. And it also means you can have two development teams, one that's working on the interface and the other that's working on the functionality of the program. And I know a lot of people just work by themselves, but it doesn't matter. You still have that sort of logical separation. Now, how does the command line interface work? Well, anybody that's used DOS or anything like that has used a command line interface. It's essentially you type something. It's a conversation with the computer. You type something, it types something back. You type something, you know. And when it's ready to have you say some more, it puts up a little prompt. And obviously, you can make a graphic user interface. So you can have a big text box with a small text box at the bottom, and you type stuff and it types stuff in the top. It doesn't have to be like a console app, but it could be. And so now I'm going to erase all this. And redraw those two rectangles as little tiny things. Because they're really not a big deal. It's not that hard to figure out what the program's supposed to do, make a high-level functional API for that, and to organize the data into lists that have indexes so that they can be accessed fast, and have associations so that an item in one list can be associated with things in another list. Okay, but now you got this command processor. So you have a command processor that takes in a string and outputs a string. And in the process, what it does here in the middle may muck with your data. So it may come over here and do something, or it may just retrieve information from the data. Like if you have an application like for banking, like what's my balance in this account? Okay, well, it's not going to change anything, but it's going to go over the data, find out what the data is, and return a string with that information. Or if it's a transfer, it's going to go over to that data, it's going to debit one account and credit another account, so the transfer operation is done. And then it's going to come back and tell you, okay, your money was transferred. It might give you more details. At such and such a time, da 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 da. Okay. So, what does this code look like? Well, it couldn't be easier. Actually, it could get complicated, but well, let's just pretend that it'll be simple. And so, it's really a switch statement. And it's parsed the command into the multiple parameters, the first one being the actual name of the command. And it's going to switch on that command. And then it's going to take you to a case where the case is transfer. And then in this case, it'll do whatever it takes, but it's not much because it's just going to call the transfer function with the remaining parameters. And then it'll break. And then that switch statement just runs. Each command runs through it, and it accesses the API. You've got a simple interface. You can actually sit down and test your program to make sure it works. Now, you can do more than that though, because in front of this command processor, there's going to be a priority queue, because these commands may come in faster than you can actually do them. And so these commands will get queued up. So CMD, whatever it is, CMD, whatever it is, and CMD, whatever it is. And then the queue is going to manage these and send them one at a time to the command processor and make sure they get done. And this is where the thing becomes, you get a lot of benefit from this, because this is where things can be very scalable. The commands don't actually have to be executed on the same computer. At some point, one computer may not be enough to manage this thing. Also, it's not, in a democratic world, when you get in line for a movie ticket, like, whoever gets there first, gets their tickets first. This is actually a priority queue, because there may be commands that are more important than others that will like sort of skip ahead in this queue. So that's being managed here. Now, when you think of a command line interface, you think of somebody like sitting there and typing commands, right? But they don't have to come from the keyboard. They could just as easily come from a file. And so part of the command, the queue manager, is that if a command comes in, like something like start up in the morning, with parameters or something, and it goes and it looks at the list of all the API things that you've written and it's not there, then it's going to go look in a directory on your system, and it's going to look for a file that'll be full of commands, right? And it'll just change its input path. It's not going to necessarily come from the keyboard anymore, but it's going to come from this file. What does that mean? So the guy, the manager of the place, there may be, I don't know anything about banking, but maybe you have to reconcile everything in the morning. You have to make sure there's no outstanding transfers or whatever it is. And the manager would do these one at a time, perhaps. Or he'd decide, well, I'll just put them all in a file and I'll call it startup in the morning, or whatever he wants to call it. Now, the command processor is recursive. It can call itself. And so if in the middle of executing one of these files, it gets to another command that is in fact not in the list of commands, then it can go look for that in the file directory, start another copy of itself, execute all those commands, and only when it's done does it start up with the next level of command. Okay, now, what can you do with this? Well, it makes testing very easy. Because you can have, like, while you're developing this thing, you can have all these test cases. And instead of like paying testers to sit here and punch buttons and then try it again with the telephony interface, the functionality of the program can be tested by just creating test scripts that call all the right commands. And remember, it was string in and string out. And when you're running the test thing, you've rerouted the input to come from some file. And you can reroute the output to come to some file. And then it's just a question of comparing that file with what it's supposed to be, and your testing is done. Right? If there's anything wrong, if I transfer, $382 to this account, well, I can test, like, is it there? And ask for the balance of both of those accounts, make that part of the test, and then reroute this whole thing to a file, have a test file that it compares it with, and there you go. Now, the other advantage is you're already set up for a client-server environment. These commands can come from anywhere on the planet. They don't have to come from the current computer. The input, I didn't say where the arrow came from. We know it could come from a file, or it could come from the keyboard. It could also come from the internet, somebody far away. Now, when this command comes in, it doesn't have to have just this information. It could also have who sent this information, who's asking for a transfer. Because this design has security built in. And of course, especially for a bank, you don't want anybody to know what your bank is doing. You're getting that Russian money and you're putting it in Trump's account. You can't just do that in the open. So these commands can come in with public encryption, public key encryption. And what does that do? It prevents anybody from knowing what a command is, because if they know what the command is, then they can do a transfer. They can surreptitiously put in a transfer. So you have to have strong encryption, and it also it verifies who sent it, because that's the way public key encryption works. It guarantees that you're getting a message. So, right, if I get a message from one of my fellow Hong Kong protesters, like, we're all going to meet, behind the, I need to know that nobody knows where we're meeting, and I also need to know that I'm not being set up, that it's not the Communist Party that's sending me this message telling me that we're going to meet behind the stadium, and then when we get there, they're waiting for us, right? So this command structure, this having commands come through a command processor, allows you to have client-server operation, so they can come from all over the world, verify who it is, nobody else knows, and that other people don't know how to put commands in because it'll be encrypted. It'll be encrypted with strong encryption. Now, this command processor doesn't have to do the work. It can delegate the actual job to another computer. And so you can have multiple servers. And so this thing is already set up for scalability. Like a lot of servers if you need it. I mean, sure, when you start, you're going to have one computer and everything's going to be fine. Then, you know, because the bank only had 100 customers. Then when the bank gets, 100 million customers, you're not going to have to throw this thing away. You're just going to get a bunch of servers, and the command processor will be sending this out to different servers. And they can be sent out asynchronously or synchronously. If they're sent out asynchronously, you're going to have to come up with a system of locks. Like if you're transferring and you're transferring it asynchronously, you're going to have semaphores blocking anybody from querying what the balances are until after the transfer is completed. Okay, now, this is so much better than putting the functionality in the event handlers over here, but the truth of the matter is, nobody likes this interface, except for maybe other computers, right? By the way, if a web service, this is now a web service, right? A web service is just a URL where you send a string and you get a string back. And so it's set up to do that. But that's fine as a web service. What about the actual user? Well, the interface code is still just as easy, right? It's like paint, I'll put this button here, I'll make it red. I'll put this button here, I'll make this drop-down menu, I'll have a slider bar, whatever it is. And then when you code the event handler, what do? You just pick whatever command it is that you wanted to get. And then that command goes over to the command processor, and then a string comes back. What do you do with that string? Well, it might be like, well, what was the balance for the last 40 days? Well, you're going to get a string of 40 numbers. Okay, well, that's not the way people like to look at things. So this program then takes that string of 40 numbers and makes the bar chart or whatever it is. And because all the functionality comes through here, when you throw away the interface, you don't have to throw away the functionality. The customer, banking was finished. They had the functionality of banking done in the 1400s in Florence. Italians figured out how to do banking and the double entry bookkeeping and all that stuff. And the functionality has not changed to this day. But the interface changes all the time. Okay, so, I told you they want a Windows program. So you wrote the Windows program. Then they wanted a touchscreen kiosk in the lobby of the bank. Then they wanted some telephony thing where you call up and you press 1 if you want this, and press 2. Then they realized that everybody hates that. So they don't want that anymore, and so they want a little web app, right? So people can do this do their banking from their home, from their computer. Then they find out a lot of people don't even want to do that. They want an app on their phone, right? Now, if you rewrite the functionality through event handlers for all of these things, what a maintenance nightmare you're getting yourself into, because
Job security.
well, Job security,
Not kidding.
but it's a crummy job.
Yeah.
Anyway, and then soon you'll get drift. If you open the account from the phone, you get the free toaster. But if you do it from the web page, nobody updated that it was going to get a free poster. But if the web page and the phone app both have to go through this command thing, then when you added the free toaster to the open account thing, then everybody gets it exactly the same. There's no difference in the functionality from one interface to the other. So that's the idea of this. What happens with the management of teams? Well, essentially it's pretty easy because they're each managing their own little piece of this functionality. So they shouldn't be any coupling. There should be, at this level, the code, there's nothing about the withdrawal code that has to go see what's happening with add a new customer. And so there's no coupling between these functional units. So you can assign them to different people, and there'll be a disparity in the level of code, but at least one person's code can't mess up another's. And if something doesn't work, you can replace that piece without too much trouble. And the testing goes quick and easy without, because testing will get left behind if you don't do it, and it will bite you. The first case of somebody getting killed by software was a radiation machine that radiated parts of your body to kill cancer, and there was no connection. Well, it had an internal register where it kept track. This is historical, I think of the 50s or something. It had a little register where it kept track of the numbers that you plugged in. And then there was a separate register where that number was displayed on the outside of the unit. And what happened is if you put in 300 rads, and that's a reasonable dose, I guess, and then you go, and then that goes into this register as well. Then you hit backspace 3 times, so this goes away, but it didn't go away in the internal register. And so then you changed it to 250 rads. Well, up here you got 300,250 because the backspace didn't affect the internal register. And 300,000 rads is a lethal dose, and the patient did die. And this is the first known case of someone dying because of a software error. I'm sure the programmer felt terrible, but it really wasn't his fault, because code has to be tested independent of the programmers. You can't count on programmers to test their own code. If they had thought of something, they would have coded it correctly in the first place. And so you got to get somebody else to test this stuff. And then there's other stuff too. I actually worked on some medical equipment, and there has to be internal hardware stuff that prevents lethal things from happening, regardless of what anybody does on the interface. So that's any questions?
No?
This works even with small apps, and it's kind of cool. Among other things you can do, I do this artwork. It's actually an AI. It's an evolutionary thing, and I do this artwork, and so I've made an interface where you click on different things, But then this just sends a command to the command processor. Now, one thing the command processor can do is keep a record of all the commands. For example, if you're a bank, you're going to keep a record of all the commands. You know who did what at every time. And not only that, if somebody does something wrong, you can have that list of all commands stored, right? And you could say, well, this command was wrong. You know, they put 300,250 and they meant to only put 250. You can go edit that one command, restore a backup of where you were before this whole thing started, and then just run all those commands back through the system. So, and when I do that artwork thing, it's kind of interactive. So I might click, it's an evolutionary thing. So I might like say, well, mate, okay. So it means all the ones that were selected to survive are now mating with each other and having children. Okay, so I just, I don't like typing things, so I'll just click on the mate button. Actually, I got this thing up too in a little box, and what I see is I'll actually see the word mate appear, and then the results of that command, I'll see it there. But you don't have to let the customer see that, it's just that, it's my own code. So I like to see what it's doing. And then if I get to the end, and I'm like, this is really cool. Okay, I can take that whole list of commands, everything I did in that session, I can save that to a file. And now, if I want to do it again, I just say do it. And that's the name of the file that it was put in. So it's just going to go get all those same commands. Now, otherwise, what I have to do, I have to replicate all that mousing and clicking, right? And so, and that's, see, there's advantages and disadvantages of a GUI interface. A lot of advantages because you can tell what you're doing and you don't have to remember silly commands for things. But if you're going to repeat processes over and over and over, then you don't want to, mouse and click around. You want to have some way, the fact that it went through a command processor and got stored lets you then replicate that set of commands. So this is, play around with this. It's actually worthwhile to, set this up. And then, keep selling the same code to customer after customer, and very reliable code, and code that's well tested, code that's secure, code that's scalable. And so this is the advantage of this design.
To give a little bit of unsolicited credibility to what Tom has said, I've had a little over 40 years of experience in software development, and the first 20 to 25 years of that, I didn't write programs like he described. The last, 25 years of my career, I write programs like he describes. In other words, I have arrived, perhaps heuristically, at essentially the same conclusion that he has. Okay, I would write and design the code and the interaction between the components pretty much, as he's described them. I suppose if I were going to maybe use some fancy words and try to sum your talk into as few words as possible, I might use.
That's not my business. I talk a lot.
I might use
Few words?
I might use words like separate abstract and encapsulate as the underlying concepts that you've described here. But Tom's spot on with pretty much everything he said here, I mean, in my opinion, so, there you go.
I'm not sure this is, first of all, I don't think we are computer scientists. I have 2 degrees, the master and the PhD in computer science, but I think computer alchemist would be a better description, because we are at that stage where, we're just banging rocks against each other and hoping, something happens. And, we may never get out of this stage, because if the alchemists had been able to create gold, we would never have had chemistry. It's like, oh yeah, very nice, your atoms and molecules. Excuse me, I gotta go make some more gold. And it's like, and we are at that stage. Without it being scientific or replicatable or anything, we're making things that are valuable. So we're like alchemists, except that we're making gold and they weren't. So it's and I'm not sure that this is the best way.
Well,
And
like I said at the beginning,
yeah,
I've never had a class.
I'm not saying it's the best, I'm not saying it's the best way either. It's something, it's a process that's been arrived at iteratively through the school of hard knocks. I mean,
yeah, I had this job, and I was working for a software company, and we got some contract from some company in Europe, and they require ISO 9000. Have you ever heard of ISO 9000?
yeah.
It's a horrible thing with a lot of paperwork. But the idea is that every process that you do has to be documented. And then it has to be scored each time you do it. So that, and the idea is like sharpening a pencil. Okay, I would jam the pencil in with my left hand. I will turn the crank counterclockwise with my right hand. And then at the end, I will try and test the sharpness of the point. And like just tons of paperwork. The funny part was the guy who ran the company said, we should write some software that would sort of automate this whole ISO 9000 process. And he wanted to call it ISO Easy. And then my intern started going, me so horny. But, it's like, so there is a value in having a process. Even if it's not that great a process, there's a value in having a process, because as you go through the process, if it's orderly, if you got steps to it and stuff, you may decide, oh, this is crap. So you cross it out and change it. But if you start with no process, and this is the way people design software, without a process, then even if you get lucky and end up with a good design, there's a good chance you won't be able to replicate it the next time. So this may, and I'm curious, if anybody has any experience or plays around with this, and you find out that something works better. Like, I'd love to know. And so I'm gonna put my email up here. And be patient, because since I retired, I stopped reading my emails on a regular basis. So, I need a flush chain icon.
Just going back to bulletin board service, post it and wait, see what happens.
Well, what I do is I answer my phone, so I'll put that up too.
I don't talk to people on the phone.
You don't talk to people, yeah, young people don't. My son won't talk to anybody, but you text people, right?
Yeah, I have to.
Okay, well. There's actually a two-step process. You gotta send me an email and then text
And then say, hey, check your
to
email.
let me
Yeah.
know to go look at it.
Alright.
My name here. I had thousands of students, and there may be like 7 or 8 that still call me and occasionally ask for advice, but I'm happy to do it. So if you need, I don't think you're gonna need help with this, it's just not that,
But you, I mean,
but
somebody to bounce something up with.
yeah, that's probably the benefit